Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020, and this is the lecture entitled The Chain Rule, Derivatives of Composite Functions. Things are getting more complicated. This is the statement of the chain rule. Suppose that we have two functions, f and g, and they're both differentiable, and we're saying that capital F of x is f composed with g. Now this means this is little f of g of x. So the little f is on the outside. Then the derivative of capital F, the composite of the functions, is you take the derivative of the outside and then times the derivative of the inside. Another way to say this is if we have y equal f of u and u equal g of x, then the derivative of y with respect to x is dy du times du dx. It almost looks like those cancel out, except that's just the cleverness of Leibniz notation. So the point is you always start with the outermost function and take the derivatives as you go in. Some people say it is like an onion. You take the outer layer of the onion, then the next layer, then the next layer. Examples are the best way for us to deal with this. So here we're going to take the chain rule to differentiate r of z is equal to the square root of 5z minus 8. Now we'd used the definition of the derivative to calculate this one before, but now this is the same thing as, you see, f of z, the outside function, is the square root function, and then inside you have 5z minus 8. So when you take the derivative of this, what you're going to do is say r prime of z is going to be the derivative of the outside function. So this is 5z minus 8 to the 1/2. So it's going to be 1/2 times 5z minus 8 whole to the minus 1/2, and then we go to the next layer and we take the derivative of 5z minus 8 and we get 5. So you see when we simplify this, and that's what I did here, so it was 1/2 5z minus 8 to the minus 1/2 times 5, and we simplify it, we can have this expression. And that's the same answer as we got before. Do another example. Here the function on the outside is the sine, and on the inside it is 3x squared plus x. So we're going to start on the outside, so the derivative of this is going to be the cosine of that same business. You leave that alone. And then times the derivative of the function that is inside, and that is going to be 6x plus 1. Now if we were to simplify this, we could write this in a different way, and I'm probably going to ask you to plug in numbers, but that's how you would do the derivative of this one. Again, you start on the outside, work your way inside. Let's look at yet another example. Y equals f of t is equal to 2t cubed plus cosine of t whole thing to the 50. So you see what's on the outside is the whole thing to the 50. So what happens is you're going to say it is 50 times this business to the 49 times the derivative of the inside function. But that is going to be 6t squared, and the derivative of the cosine is minus sine of t. And so, and there's different ways you could write that. This would be fine, but you could also write it like this because that's the way, many people feel that that's a proper form to write it. But I'm going to count either one of those right. As long as the derivative is right, I will count it right. Let's look at this one. Now, the function on the outside is e to this business, and on the inside is 4, or it is w to the 4th minus 3w squared plus 9. So the derivative of this is going to be, the derivative of e to the something is e to the something times the derivative of what was inside. And this is going to be 4w cubed minus 6w. So that's how you do this. Remember, we leave the inside function alone when differentiating the outside function. So the derivative of the exponential function with the inside left alone is just the original function. Let's do a trig example. Here, y is equal to the secant of 1 minus 5x. Now this is the secant of that, it's not the secant times that, because the secant is a function itself. So on the outside is the secant, on the inside is 1 minus 5x. So you see we're going to take the derivative of the secant. The derivative of the secant is the secant of this times the tangent of this. And now I'm going to move inside. I'm going to take the derivative of this function, which is with respect to x, which is just minus 5. So this is going to be minus 5 secant of this business times tangent of this business. I'm going to see you in 16.1.